Hi, this is Warner Chavez with Pluralsight, and welcome to my course, Azure SQL Data Warehouse First Look. This course is an introduction to the main concepts of SQL Data Warehouse, provisioning, designing, and maintaining the system. This is Module 1, Warehousing in the Cloud. In this module, we're going to go over the main concepts of Azure SQL Data Warehouse that you need to understand in order to jump in and start using the service. We're also going to go through the biggest advantages of doing warehousing in the cloud, especially as opposed to doing traditional on-premises data warehousing. Finally, we're going to go into how the service is built and how you can provision your data warehouse in the Microsoft Azure cloud environment. So first, what is Azure SQL Data Warehouse? It's a service that lives on Microsoft Azure, Microsoft's offering of public cloud data centers. It's also a platform as a service offering, also known as database as a service. That means that you don't have to manage the operating system on anything below that. The only thing you have to worry about is about loading and querying your database. It's also a massively parallel processing system. So as opposed to the usual traditional warehousing where it's one big machine, this is actually a distributed system where different computers called nodes cooperate to give you the answers to your queries. Because of the way Azure SQL Data Warehouse works, where it's split into multiple machines, it depends on distributed storage. And like we just said, because it uses multiple machines to compute the answers to the queries, it is also distributed compute. So an SMP system, or symmetric multiprocessing system, would be more like the classical SQL Server that you're probably familiar with, and that usually that is one large machine, either on-premises on the client, physical or virtualized. An MPP system, on the other hand, is a massively parallel processing system. These types of systems are composed of multiple machines, not just one big machine. Usually, these machines will all have a slice of the data from the database, and when a query comes in, there is a coordination done of query execution planning so that there's distributed work that happens on each machine in order to get you the answer to your queries. This scales very well as the amount of data increases. In Azure SQL Data Warehouse, we have a concept called the Data Warehousing Unit. This is a measure of the underlying compute power of the database. What this means is that on Azure SQL Data Warehouse, you don't have to select specific configurations of CPUs, RAM, or storage. The only thing you have to worry about is the amount of data warehousing units that you provision. Let's check out an example. Let's say I provision a data warehouse with 100 DW units. I did a test, and then I loaded 3 tables in 15 minutes. I ran a report, and then my report came back in 20 minutes. I then adjusted my data warehouse and increased my compute power to 500 data warehousing units. When I ran my test again, this time I loaded 3 tables in 3 minutes, and I ran my report in 4 minutes. Basically, the data warehousing unit is a comparison unit. If I do a workload in 100 data warehousing units, and then I increase that 5-fold to 500 data warehousing units, I should expect an approximate 5 times improvement on my workload. So why choose the cloud over on-premises traditional warehousing? There are several good reasons. First, in the cloud, you don't need to do large capital expenses to get started. On-premises, it can be really hard to get all the approvals and justify the big expense of buying large warehousing machines and licensing. In the cloud, you don't need a lot of staff to maintain your hardware solution, the virtualization, or the operating system. Like I mentioned before, Azure SQL Data Warehouse is a platform as a service offering, so all these things are taken care for you. All you need to do is manage the database itself. Finally, something that is very difficult to do on premises is to scale storage and compute up or down on demand. Usually, you do a big investment and you can't scale it down at all. Or if you want to scale up, this usually takes time to provision and set up the extra compute power. These operations, on the other hand, can happen transparently and in minutes in the cloud. So how is Azure SQL Data Warehouse built? First of all, there's a component of storage that you have to pay, and it is billed by the gigabyte, usually monthly. You have two choices of storage. There's standard or premium geo-redundant storage. Right now, it depends on the region where you are creating your data warehouse, whether you will get standard or you will get premium storage. There is no cost for storage transactions. This is different from the standard way in which blob storage works. Sometimes you can be charged depending on a large amount of storage transactions. This is not how it works with Azure SQL Data Warehouse. You only pay for the amount of storage, not for the transactions itself. Finally, outbound data transfer is billed as well. So if you are loading a lot of data into your data warehouse, you will not get charges for that. But if you are also taking out a lot of data out of your data warehouse and out of the Azure data center, that will have an outbound data transfer charge. The other piece of how the service is built is the compute power. Like we mentioned, the data warehousing unit. So, the amount of data warehousing units can go from 100, which is the minimum, to 2,000 data warehousing units in one database. That means you can go from a base performance to about 20 times that base performance. Data warehousing units are built per hour. So if, for example, you increase from 100 data warehousing units to 500, you will get billed that hour for 500 data warehousing units. If on the next hour you bring it back down, then again you will go back to paying 100 data warehousing units. However, if 1 hour has two different values of warehousing units, you will pay for the highest one during that hour. When not in use, compute power of the Azure SQL Data Warehouse can actually be completely paused for maximum savings. So if, for example, your data warehouse gets no use during the weekends, you can pause it completely and save yourself that cost. While the fundamentals and best practices of the service will remain the same, in the cloud it is common for service providers to change details like the service limits or the pricing. In order to get the latest info, refer to azure.com. Let me show you where. I'm on the homepage right now for www.azure.com. Here, we can just go to pricing. On the pricing page, scroll down and you'll get a list of all the services. Azure SQL Data Warehouse is located under Data plus Storage. We'll just click there. In this page, we can get the details and the pricing for SQL Data Warehouse. We can get the limits on compute, like the 100 DW lower limit and the price for it, as well as the current maximum DW limit, 2000, and the price for it. If we keep scrolling down, we'll also get the limits on the storage and currently which regions have premium storage and which regions have standard storage at the moment. For the documentation, it's the same. We can click on documentation and then go to data plus storage, and then here go to SQL Data Warehouse, and we can access the full homepage of documentation for the service. Let's check out a demo of provisioning a data warehouse through the Azure web portal. I'm connected now to my Azure subscription, and this is the dashboard. Just have to go to New. Once we're at New, we look for the Data plus Storage option in the blade. And once we're at Data and Storage, we have the option of SQL Data Warehouse. Note that it will say that it's in preview. As of the moment of this recording, it is not on general availability yet. First thing, we just have to pick a database name. In this case, I'll just name it Warner Warehouse. Next, we will select either to use an existing resource group or create a new one. I'm going to create a new one called Warehouses. Then we select the origin of the data, blank, a sample database from Microsoft, or a backup from another warehouse. I'll just leave it blank in this case. And I'm going to create a new server as part of the demo so that you can see the entire process end to end. I'll just name the server Warner Data Warehouse. Then I have to set up an admin login and a secure password. After I've set up the password, it's time to pick the location of the server. And here you have to select depending on your business needs or data sources. I'm going to select East US in this case. At this point everything's ready. I just pick on select. Now we have the server information populated on the warehouse blade. We can pick the performance level or the data warehousing units. In this case the default is 400, but I'm going to change it to 100. Once I've selected it and changed it to 100, I'll actually get an estimation from Azure of the cost per hour. In this case, it's 85 Canadian dollar cents per hour. If that sounds good, then just click Create, and the deployment will get submitted to the Azure Fabric. Once we verify that the deployment is submitted, it's just a matter of waiting until it's completed. That can take a few minutes. We'll get a notification once it has completed. In this case, we'll know that deployment has succeeded if we don't come up with any errors from the portal. We can actually go back and search for warehouses, and that'll lead us to our Azure SQL server that we created, and we can make sure that the server was created correctly in the region that we wanted. You can also verify that it was created with one database inside, database called Warner Warehouse, and we can see the data warehouse level there as the W100 as well. We can click and expand on the warehouse blade as well. And here we can also go into the server name so that we can try to connect and actually run a query against our data warehouse. We'll just click to copy the server name. Then we can paste that server name into Management Studio and use the admin account that I created when I created the server. Now if I try to connect at this point in time, I'm going to get an error because we don't have a firewall rule to allow my virtual machine to connect to my data warehouse. So let's check how we can allow my machine in the portal as well. So let's go back to the portal. We'll go back to the server blade so we can close the warehouse blade. Go to the settings and then go to the firewall configuration setting at the server level. Once on the firewall blade, we can add the client IP if we're connected to the machine we want to whitelist, and save the new setting on the firewall. We got a message that it was successfully updated, so we can try our connection again. Now we'll just try to reconnect. This time it goes through. We can verify we're connected to Warner Data Warehouses. We expand the databases. We can see the Warner Warehouse database has been created, and I can now run queries against it as well. So I'll select the database, go to New Query, and then just run a simple select at version query so we can verify that we're indeed running on the warehouse edition of SQL Server. And actually expand the result set, and we can see that the product name here is Parallel Data Warehouse, which is the name of the version of SQL Server that is the distributed MPP Data Warehouse Edition. Let's see a demo of provisioning the Azure SQL Data Warehouse with Azure PowerShell. Okay, so before running PowerShell scripts, you need to install the Azure PowerShell. Just go to www.azure.com and search for Azure PowerShell. You'll be able to find the installation package. Once you have that going, You can set up your account first by using the Login Azure RM account. That will prompt you for your credentials for your Azure subscription. After that, if you have multiple Azure subscriptions, you can pick a preferred one to create the objects and use as your default. If you want to see the subscriptions that you have, you can use Get Azure RM Subscription, and it'll give you a list of your subscriptions. And then you can select your default subscription by using Get Azure RM Subscription, passing the subscription as the parameter name, subscription name, and then piping that into Select Azure RM Subscription. Once you have your login set up and you have selected your default subscription, we can move forward with actually creating the data warehouse. Let's look into that. So here's the commandlet to create a new data warehouse. Commandlet is new Azure RM SQL database. We have to pass in the requested service objective name, or basically the amount of data warehousing units that we want for our data warehouse. In this case, I am passing the W100, so 100 data warehousing units. I then pass a database name. In this case, I'm just calling it Warner Warehouse P Shell. I have to pass a server name, so if the server did not exist, you should create it before that. In this case, I am using the server that I created in the previous demo. Then I'm passing in the resource group name. I'm also using the resource group that I created in the previous demo called warehouses. And then finally, I'm just passing the addition. In this case, it's a data warehouse so that it instantiates as an Azure SQL data warehouse and not a regular SQL database. Once we have all those pieces, we can actually run the command. After a few minutes, the data warehouse will have been created, and we can verify in the output. We can see a resource group name, the warehouses, the server name that we specified, the new database name, the Warner Warehouse P Shell, the location, in this case is East US, and all the other different configuration values for deployment, including collation, status, creation date, etc. At this point, since we didn't get any errors in the output, we can go into Management Studio, where I already connected to the Warner Data Warehouses server. I can refresh the list. As you can see, we have not only the Warner Warehouse we created with the web portal, but we also have the new one, Warner Warehouse P Shell, that we created through the PowerShell. In this module, we learned that Azure SQL Data Warehouse is a platform as a service offering inside Microsoft Azure. We learned that it offers multiple advantages over traditional on-premises warehousing, such as decrease of staff, easiness of scaling up or down the resources, and not having to do a large upfront investment. We also learned that the service is built based on two components, the storage and the compute can also be changed based on the data warehousing unit or how much of those units you need. And finally, we learned that there's different methods that we can use to provision the service depending on what we want to do, either one-off through the web portal or easily to code it through T-SQL or PowerShell. Join me for the next module where we're going to go through designing our Azure SQL Data Warehouse. As you try out Azure SQL Data Warehouse and you get further into the service, it's critical to realize that it doesn't have the same nature as SQL Server like you're used to it on premises. Azure SQL Data Warehouse will require different design decisions than if you were building an SMP SQL Server due to its different nature as a massively parallel processing system. Let's go through some of those design decisions in this module. The biggest difference from the symmetric multiprocessing nature of SQL Server is the fact that Azure SQL Data Warehouse always has a distribution key for its tables. This distribution key will determine the method that Azure SQL Data Warehouse is used to express the data across multiple different nodes and storage. Every time that you create a table and you load data into Azure SQL Data Warehouse, it's going to split that table in 60 distributions. Think of that as 60 different buckets for data. And then those distributions will get attached to different nodes that will do some compute. For example, let's look at a hash distribution. Let's say we're distributing by the product column. So first row arrives Azure SQL Data Warehouse, system will hash the value of volleyball and put it in node 1. Second row will arrive to Azure SQL Data Warehouse with the same value of volleyball for the product column. It will get hashed to the same value and also arrive at node 1. The third row, on the other hand, has a different value. It has a value of basketball, which hashes to a different value, and then it gets assigned to node number 3. There is also round-robin distribution for records. In a round-robin distribution, the content of the records does not matter. The system will simply take each row and distribute them evenly amongst all the nodes of the service. So record number 1 will go to the distribution number 1, record number 2 will go to distribution number 2, record number 3 will go to distribution number 3. When choosing a distribution method, the most important thing is to avoid a data skew on the distributions. A data skew scenario is one where the vast majority of the data is left in one distribution, and then we have other distributions like the green one that actually have a very small amount of data. This affects the performance of the system because it's a massively parallel system and we want to have equal amounts of work for all the nodes to do. On an even distribution, all the nodes will have the same amount of data assigned to them, and they can all perform similar amount of work when a query happens. This is what we want in our system. All of them doing work at the same time. So what makes a good hash key if we're going to pick a hash distribution? First of all, the most important characteristic is that it distributes evenly. As we mentioned, that is critical so that we take full advantage of the compute power of Azure SQL Data Warehouse. Second, we want the hash key to be used for grouping so that all the records that are going to be grouped are already on the same distribution. We also want the hash key to be used as join condition, especially amongst large fact tables, so that those same records that match on the join are in the same distribution and we can avoid data movement. Fourth, the hash key column is not updatable. If you need to change it, you will have to delete it and reinsert the record. So it's better if it's just a column that is never going to be updated. And 5, we mentioned that Azure SQL Data Warehouse will split a table into 60 different buckets called distributions. So we want a column that has, at the very least, more than 60 distinct values, so that all distributions get some amount of data. If you think about it, you will easily realize that a round-robin distribution will always provide an evenly distributed system. However, it might not necessarily provide the best performance. This is because the data that has the same value that could be used for the grouping or the joins might end up on separate distributions and separate compute nodes. Let's talk about data types on Azure SQL Data Warehouse. We want to use the smallest data type which will support your data. This applies to integer values, it applies to character values, and it applies between choosing into ASCII or Unicode or varchar and mvarchar data types. If you have character columns, think about the default length that they have and avoid defining them all to a very large default value, even if you're not using it. For example, if a column usually only uses 20 characters, don't define it to 100 characters just to be safe. As always, inspect your data and make sure that if you are choosing Unicode columns, it's for a reason. Unicode will take twice as much space as the regular varchar column. The goal in choosing the smallest data types and the smallest default length possible for character types is not only to save space, but also to move data as efficiently as possible between different compute nodes. This type of data movement does not happen on an on-premises SMP SQL server, but Azure SQL Data Warehouse, being a massively parallel processing system, might have to do data movement to resolve a query. Keep in mind as well that at this point in time, some complex data types, such as XML, geography, and others, are not supported on Azure SQL Data Warehouse yet. For the latest info, as we mentioned before, refer to azure.com.